today's objective is to compare and contrast GATE BM 2020 paper and GATE BM 2021 paper. Not qualitative reviews, paper was good, easy, bad, but we want to actually see some numbers. We want to make the review quantitative. Okay, how many difficult questions, how many questions from so and so subject. The idea is such a number would be helpful for preparation of subsequent exams. In general, 2020 paper is one of the easiest papers. Okay, very biomedical friendly. And 2021 paper is a relatively hard paper, and it's also very biomedical unfriendly. What do we mean by biomedical friendly? Unfriendly will become evident by the end of this class, but these two are in pretty much two opposite ends of the spectrum. One is in the Kashmir, one is in at Kanyakumari. So getting to know them will help us plan pretty much for any paper. So what's the objective of today's class? So a quick statistics on what comparison between 2020 paper and 2021 paper. So All India rank 1 in 2020 paper scored 41.6. This is out of 100. 2021 All India rank 1 scored 64 out of 100. So interestingly, the rank 1 doesn't really reflect how easy or hard the paper is. Just that no one knew this was the first paper. No one knew what they will ask, what kind of questions will show. Accordingly, even the All India rank 1 was lesser. 2021, we had some idea on what they are going to ask. So the All India rank 1 kind of went up. And cutoffs, of course, we have 3 categories, GATE, and accordingly, the general category cutoff is like 25 in 4. This year, if it increases, it might increase by 2 or 3 marks, so not a lot. And around 2,200 students, 2,300 students give the biomedical exam, at least register for it. Not all those who register for the exam actually give the exam. Okay, for example, these are the number of students who actually gave the exam. These are the number of students who registered. And in 2020, the number of qualified students were very less, 58. And those who scored All India rank 24, 34 and all had tough time getting a seat at IITs. In 2021, qualified students is certainly above 150, something like that. So this is above 150. And yeah, typically, if you had scored 35 plus in 2021 exam, you are kind of in the safe zone. Especially with the general category. Then based on your category, you had some even for some students even scores like 25 and all that. So this is some very basic statistics. Now we'll get into details of the question paper. Okay. Now what we are going to do at the end of the session is this. So fill up this table. I have various subjects here: general aptitude, engineering math, HAP, biomechanics, sensors, and so on. So here I have the BM subjects, and that is HAP, biomechanics, sensors, and bioinstrumentation, medical imaging, biomaterials. These are specifically there in biomedical syllabus, subjects in biomedical. And then we have some interdisciplinary subjects: electrical circuits, signals and systems, analog electronics, digital electronics, measurements and control systems. So let's say these is non-B. So our objective is to actually fill up this 4 columns. In 2020, how many marks showed up from general aptitude? That's a fixed number: 15 in 2020, 15 in 2021. If we take it engineering math, was it 12, 11 in 2020? Then was it 20, 21? Was it the same? Okay, what was the number? HAP, how many marks showed up? Total marks from HAP, okay, in the whole paper. That we have to fill up. As we do this, we also want to look at, okay, let's say 15 marks showed up from general aptitude. How many marks were like really hard? even for a AIR, one student is like relatively hard to get those marks. Okay. Let's also note this down. So these two columns, comparing these two columns will help us see, what is most weighted subject, how does the weightage change over, two extremes. That is one thing. And then also by looking at how many marks were like really difficult to get, we can also say, okay, how difficult was the paper? And the total here will tell us, was the paper BM friendly or non-BM? Yeah. So subject-wise weightage and relative, difficulty, subject-wise difficulty. So two things we want to compare and contrast quantitatively in 2020 and 2020. That is based on the number of marks that shown. And I need, we want to work together filling this table. So let's find some volunteers who would keep track of scores. So let's start with, some students who already know how the score, keeping track of scores and updates and all that work. So I'll ask you once. If you agree, then you take care of a particular subject. Else, I'll just move on to the next person. So what we are going to do is we are going to go through 2020 paper, 2021 paper. Then each question will say whether it's engineering math question, whether the question was hard or difficult. We want you to keep track of total number of marks. And the moment, okay, so URB is for engineering math. The moment you come across engineering math, make a note of it and update the total count in the chat. Okay, total marks as well as questions that marks corresponding to hard questions. I suppose, all the subjects are allotted. Okay, general aptitude, we can do that as a class, as a whole, and then we can see the trials. I already filled this up, 15 marks from general aptitude, 15 from this. Hard marks, we'll just note it down. Let's just do 2020 paper first, and then we'll do 2020 paper. So things are easy. Okay, so I have the 2020 paper here. And I asked everyone to actually map the questions to topics in the syllabus. So I suppose you have read all these questions. Even otherwise, most of you have seen these questions. Okay, general aptitude. We know, first 10 questions are general aptitude. Let me quickly mark the questions that are very, very hard. Okay, or relatively hard. 5 1 marks and 5 2 mark questions. Total 10 marks. English, hit or miss. So these are pretty easy questions. Question number 3 again is easy. Then we have question 4 again is easy. Sum of odd numbers, even numbers. Okay, let's take a quick vote. How many of you cannot do question number 5 right now? That is difference between sum of first two in natural numbers and sum of first in odd numbers. We are actually having few things. Okay, so the trouble here might be what is the sum of first n odd natural numbers. Okay, there is a formula for that, or there is a way to quickly calculate that. If you don't know either, it's going to be hard. Let's say this is a hard 1 mark. Okay, so there is a 1 mark question that's hard here. Then these text inference questions are all very easy. Okay, and one more thing. Okay, I will say that once we finish aptitude. So this PQRS, if you know how to do this, if you have practiced well, this is easy. Else, if you are doing it for the first time, this is certainly a hard question. Okay, so far there's a 2 mark question, so we have like a running total of this speed decision time is easy. This is easy, and then profit and share. All you need to know what is this. What is revenue? Something that you need to know. Actually, there's an easy question. So I'm just going to say for 2020, we had like 15 marks from general aptitude, and we had like, let's say 3 hard marks. Not totally ungettable, but relatively hard. Okay, now is everyone clear on what they are supposed to do? So we need number of marks here and then number of marks here for your corresponding topics. And okay, we can make some quick checks. At the end of the day, if we calculate all this, we should get 100. And similarly, if we calculate all this, we should get 100. If you are not getting 100 here and here, the sum total, we have made a mistake. Okay, so in that case, we'll stay back and count it again. Okay, but we don't want to go to that stage. So keep our counting quite precise and accurate so that our checks and balances are correct. We don't want to repeat doing the whole exercise. Okay, great. Let's get quickly started. 20-25 minutes for both the papers, then we'll have a discussion on comparing and contrasting them. Okay, first question. M1 and M2 roots of characteristic linear second order system match the roots with the natural response of the system. Okay, there is this question from, it's a very basic question.
Control systems.
Yeah, the best topic to actually put this is control system. And notice questions 1 to 25 are 1 marks. So first we have all the 1 marks here in this paper, and then we have 2 mark questions. So okay, this is a 1 mark control system question. Okay, first question from control systems. And then this is a very easy question. Okay, you have to map things. Person sitting in a chair. Okay, by this time we have seen this, the kind of 1 mark biomechanics question. So basic kinematics, what is flexion, what is extension, all the interflexion perhaps is the really the tricky one here. But this is very, very easy. Quickly, okay, we have like at least the control system tab is open, biomechanics tab is open. If you don't want to update in the chat, you make sure your count in the note is correct. Okay, equipment that measures elasticity of blood vessel in vivo is
Bioinstrumentation.
rheometer, dimensional analyzer, biomechanical analyzer. Yeah, this is the best to put it in. Elasticity of blood vessels in vivo partly comes in biomechanics, but let's just put it in bioinstrumentation, because at the end of the day we may want to know what is what about even some of the other instruments here. We want to know what is a rheometer, dynamic mechanical analyzer, and all that. So this is bioinst and just a 1 mark question. Very basic theory question. Okay. Biomaterials with shape memory effects are not used. This is biomaterials. Okay, straightforward question. And then we have 1 mark biomet. Anyone want to guess where this question is from?
Medical imaging.
Medical imaging.
Medical imaging. Okay, 1 mark from medical imaging. Okay, and this question, at least when it showed up, was very hard. But right now, it's a quick recall based question, so I'm not going to mark this as hard. The theory questions most of the time are hit or miss. Okay, so no point marking them as hard. And okay, this is primary EM radiation. Again, notice very basic questions. 1 more from medical imaging. Okay, EM radiation, especially diagnostic X-ray imaging. Then we have 5 megahertz ultrasound pulse, so and so thickness. Time for the echo is this. Okay, you change the frequency, what happens to the time taken? It is this one. Again, it's a 1 mark question from medical imaging. Notice it's one of the easiest, easy question. It's not even go there. And medical imaging, biomechanics, biomaterials we have done. So I'm going to quickly mark the questions. And it's questions that are like, we haven't seen both the sessions that we just slow down on. Yes. X of S is a Laplace transform of a signal. Laplace transform of derivative of X. There is this one.
Signals and system.
Thanks, Akansha. This is a 1 mark question. Notice it's a very, very easy question. It boils down to what the basic properties of Laplace transform is. Okay. So this is actually an easy question from SMS. Okay, thank you. So in fact, so far we haven't really hit any hard questions on this. Which of the following are odd functions? Where is this from? Sin t cos t, sin t plus cos t, sin t cos t.
Signal and system.
Yeah, this is from signals and system. We have some based on symmetry. We can, whether it's a even function, odd function, number of terms in the Fourier transform will change. Okay, we have a couple of symmetries, and something very crucial in determining that symmetry is this, whether a function is even or odd. So this is from Hessendes, and a very basic question, easy question. Say-Spitz model of a system is this: conditions for the system to be controllable. This is from, again, there is a condition for, there is something called a controllability matrix, and there is a simple condition for this. This is actually very easy if you know what it is. This is control systems. Are you all hearing my neighbor's dog?
Yes, sir.
Yes, sir.
Okay. Probably there is a visitor nearby our area, not even nearby not to their house or not to my house. Nearby, anyone shows up near the location, it starts showing. Just wait a minute or two. Okay, where are we on this? Where is this from? Where is microprocessor in the syllabus?
Analog and digital.
Analog and digital electronics, specifically digital electronics. Okay, there's a one mark question. There's a first question that I'm going to mark as hot, the core, from biomedical topics, because it's a recall based questions, but microprocessor is somewhat obscure, and the number of things you have to recall is kind of a lot. So I'm just going to, even if it's a recall, it's a hard recall. So I'm going to mark this as hard. And then number of electrodes used in recording standard bullet is electrocardiogram. One mark, bioinst, and it's an easy question, very well. So this is easy. And then which of the following is not part of major? There are going to be two types of questions. Anatomy and physiology is a ocean. Okay, but questions from musculoskeletal system, or specifically, I'm going to put them in biomechanics, because you need some basic musculoskeletal system anatomy to know biomechanics, and also it's a recurring pattern in GATE paper. There are cluster of questions from HAP questions from musculoskeletal system, be it the microstructure or details about the joints and all that. So for that reason, very easy question, recall based question, I'm going to put this in biomech. And to contrast that, I will show other HAP questions that are very biomech, and I will also show HAP questions that are not like biomechanics. During routine stethoscopic examination, left mid-clavicular.
Bioinstrumentation.
Okay, this is bioinstrumentation. One more. Okay, is our right now, perhaps in 2020, those who gave the exam might have found this very hard. But right now, this is PCG from bioinstrumentation. We know how these combinations work. Stenosis, regurgitation. We know where we will hear it and when we will hear it. So it's actually an easy question. Very simple recall question. Then notice, thin filament of a muscle fiber is comprised of
Human anatomy and physiology.
This is, yes, human anatomy and physiology, but again I am going to notice it's microstructure of muscle. Okay, how does the muscle work at a at a microstructure level? So I'm again going to put this in biomech. The reason being, this question, HAP question, and this HAP question is very predictable from HAP. Okay, so that is biomechanics. Then we have some easy questions here. Okay, one more math. Notice there is a simple complex variable question. Yeah, we know how to do this, and eigenvalues of this matrix. We know how to play around with eigenvalues and all that. Simple recursion relation. Again, this is math from numerical methods. Simple one more. So 3 one mark math questions. Okay, that's all we have. Perhaps there might be some other questions in MCQs or something. Let's check here. Okay, this is from nuclear
medicine.
Yeah, one more medical imaging. Nuclear imaging, medical imaging question. HPL, we know again all these things in and out. Very easy question. Distal end of endoscope is placed at a distance of so and so. Refractive index is this. Maximum field of view. Where is this from?
Instrumentation.
And what kind of an instrument is this? Bioinstrument is this?
Core and cladding endoscopy.
Yeah, specifically, optical. Yeah, optical type of bioinstrumentation. Bioinst. And this is, this is a standard thing to ask. There is numerical aperture and then there is field of view. Relation is very, very simple. Medium question, not really in the hard end. Hard end, perhaps I can show you some examples later. How can they make this question really hard? Okay, so this still is an easy question. 2 inductors with a given below or wound separately on 2 identical ring type magnetic cores. Where is this?
Sensors.
Yeah, this is, basically we have like, the 5 or 6 things mentioned in the syllabus: resistor, capacitor, inductor, PCT, then of course optical, electrochemical, so on, so right? So this is a basic question on inductor. And for inductor there is one relation, capacitor there is one relation, resistor there is one relation, rho L by A. Capacitor again there is something like based on what the distance is, what the area of the plate is, and all that we have some relation. So very simple question from sensors can answer this. Then we have two dyes X and Y having concentrations in the ratio. Is this so?
Bioinstrumentation.
Yeah, instrumentation. And again, can we be specific here? Spectrophotometer is a type of at the end of the day, it's a type of an optical device. Okay? The photometer, measures light intensity. So, has to one more question, simple question from bioinstrumentation. And relations. This is in fact much more simpler. You need to know what is absorbance, what is transmittance. The moment you know that, this question is actually very simple. Okay? And let's go to question 23. Hydrolysis of 1 ATP point provides an energy of dash kilocalories. Where is this from?
Physiology.
Yeah, this is one more question from HAP. This is not, you can't force put into biomechanics in any way. And this is also a question, who would remember, I suppose the answer is 7.2. Like, if it's like you have to guess if it's a MC question, you are guessing out of 4 choices. How many choices are you guessing this number out of? Unless you really know that. This is, it's a hard question. There are thousands of such numbers concerning the human body, and I don't know why they decided to ask it, but they asked it, and it's a hard question. So yeah, I mean, this is a question like even if you go through entire K-on MCQs, you know it in and out, you still can't answer this one question. Then we get here 830 nanometer laser Doppler flow meter oriented an angle. Average velocity is this. Magnitude of Doppler shift is. Okay, where is this one?
Medical imaging.
Bioinstrumentation and medical imaging.
Yeah, notice, so we looked at the concerning
Laser Doppler.
theory of Doppler shift in medical imaging. But because ultrasound Doppler is there, then we have laser Doppler, okay? Let's see where this is being applied. The theory is the same, but application here is to measure flow velocity. So this actually a question from bioinstrumentation. And at the end of the day, the Doppler shift relation we know. So it's a simple, easy question. We can't miss marks like this. And then 100 milliamp single current pulse from a generator, pulse generator, artificial fuse, and so on.
Defibrillator.
Yeah, defibrillator, bioinstrumentation. This is at the end of the day, it's a very, very simple question. Okay, what is the power dissipated in a resistor? And then so you need the energy. Power times time is energy, and there is a threshold on energy, so you can find that time. So this is one more simple bioinstrumentation question. And I am also going to bioinst highlight this question. Question like this is likely to show up in each and every paper, okay? Because you can make this calculation for, make some minor changes here and there and post it in various instruments. Okay, now what is the energy supplied by a battery? Now you can also quickly convert that into what will be the life of a battery, something like that. So it's a very important question, okay, and can be asked in many, many ways. So far, which subject had the most number of questions? Can we have a quick update? It's bioinstrumentation, I suppose, just by looking at it. And notice, send us CS and all, even if you hadn't read signals and systems, digital electronics, you're not really missing a lot. Okay, is everyone having a count, right?
Yes, sir.
Okay, now we get into 2 mark questions. So we have, the resting potential. Actually, they should call this the nudged. Okay, the resting potential is this.
Bioinstrumentation.
Yeah, this is origin of biosignals. So this is bioinstrumentation. Simple question. There is this one equation, Nernst equation, and then if you know that, is a very, very straightforward. So 2 marks, again easy. Relatively important question. Okay, Nernst potential, or it's going to be a Goldman equation, or it's going to be at the end of the day pH sensor, electrochemical sensor. Either these way they likely to ask this. Okay. Arrangement of 4 resistors of equal value in a diaphragm for physiological pressure measurement. Yeah, they kind of said it what it is. Pressure measurement.
Measurement. Bioinstrumentation.
No, it's actually
And
not
Electrical
from,
circuit.
okay, yeah, we have lots of details. Yeah, Wheatstone bridge might look like electrical circuits, and also those bridges are relatively heavily studied in measurements. But this is just a straightforward application of the strain gauge to measure pressure. This is one of the important pressure measurement devices. It's actually a bioinstrumentation question. Okay, 2 marks. And also, if you actually understand what they are asking here, the question answer is very, very simple. How should this configuration be? They should be like put opposite to each other. And the moment you know that pattern, is a very easy question. So Wheatstone bridge, this is an easy question. I will show a hard question in 2021 paper. Okay, so this is still easy. Input voltage is this functional circuit.
Analog and digital electronics.
And more specifically,
analog.
This is analog electronics. Okay, we have 2 more question. Is it easy or hard?
Easy, sir.
Yeah.
Comparator and differentiator circuit.
Yeah. See, at the end of the day, we want to know what a comparator is, and we want to know, we should recognize a differentiator. To do those 2 things, it's extremely easy question. First time when they showed up, perhaps it might have appeared hard, but right now, I know any standard op-amp circuits you should be able to identify. So I'm not going to mark this as hard. It's easy. And so there's a 2 mark bioinstrumentation question. Okay, and so at least most of you know how easy this question is. Not even worth 1 marks. Okay. At the end of the day, what is the MAP? They want you to know what is systolic pressure, diastolic pressure, and how to calculate mean arterial pressure. Even for a 1 mark, it's an easy question. They gave it in 2 marks. Fine. Then we come here. 2 loads are connected to AC supply mains as depicted in the figure. Okay, where is this from?
Electrical circuit.
Electrical circuits. Is this easy or hard?
Hard, sir.
Yes, I would partly agree with that. Okay, so it's a 2 mark question. Electrical circuits, and it's relatively hard. The reason being, all this, lagging, this kind of power factor was introduced later. So not lot of questions from this topic. It's a kind of, even for instrumentation, it's a new topic. So relatively hard. Once you understand, okay, what is this power factor, what is this kVAR, once you understand all those things, somewhat of a medium question. But to start with, let's put it in a hard question. So you need everything in electrical circuits, even Norton Thevenin systems, but at the end of the day, you may not be able to answer a question like this. Okay, yeah, nearest value of power dissipated in the 3 ohm resistor.
Easy and electrical circuit.
2 mark is easy, and this electrical circuits. Okay. In fact, they don't even ask you. It's a matter of how you find that. There are many ways to find it, and it boils down to how fast can you do this. Okay. In fact, there is one question you can do it in 4 or 5 methods. So try it all those methods in order to actually learn what is there in electrical circuits. This thing. Second order low pass filter, H1 of omega, H2 of omega, undamped natural frequency. There is this
Control system.
Control systems. Yeah, it's control system also. It shows up. Electrical circuits also kinda it shows up, but best to put it in signals and systems. Second order systems. What is a low pass filter, high pass filter, then cutoff frequency. Okay, I'm going to put this in S and S. This is for 2 marks of course. It's a easy question. Undamped natural frequency at the end of the day is very simple. You need to know what the standard form of second order systems. Make the comparison. Match the bridge type with the application given below.
Electrical circuit.
Any other answers?
Measurements.
Sensors and Measurements.
Yeah, this is actually measurements. First, in fact, measurement question shown. Okay, this, at the end of the day, they use a bridge. You need to know how to deal with AC bridges. Here, they just ask you to recall, okay, what is Maxwell bridge? What is Kelvin bridge? Notice at the end of the day, how do you measure very low resistance? How do you measure this thing called, inductance, then capacitance, and then inductance with, high Q. So this is a measurement question. Right now, it is a mapping stage, recall stage. It's very easy. What we expect you to know is actually what a Maxwell bridge is, how it works. That level of detail we expect you to know. And hard questions, they can somewhat make it harder. So show some example on this. And I'm going to mark this as important. If not, match the following theory questions like this. Recall what a Maxwell bridge or that. They can always give you a which one bridge and make you answer this. Okay, non-unity feedback system control systems. Magnitude of steady state error to a unit step impedance. Just give me 1 second. Okay, so where is question 34 from? Let's make it quick.
Control system.
Control systems, 2 marks. Is it easy, hard? Say it depends. Okay, we will make it easy for you. Certainly, we'll make it easy for you. Whatever we learn in control systems, at the end of the day, this will become easy. But notice, many are actually confused about what a non-unity feedback system is. So, there are traps here which most would fall for. Okay, unless like really one points at it. And also, there is some argument over how to calculate steady state error for such a system. Okay, I'm going to mark this as hard. We'll certainly make it easy for you, but with this one question, let me mark it as hard. Okay, let me do things quickly, things that are very, very easy. Quickly answer this. We have a 2-mark question.
Digital electronics.
Yeah, this is a digital electronics, 2-mark question. Thanks. Basic Boolean algebra, 2-mark, digital electronics. So this is again easy if you know what the Boolean algebra is. Glomerulus filtration, so and so. Okay, what is this? Any of you have seen this question also? Yeah, this is cross between bioinstrumentation and biomechanics. Take a very standard biofluid principle and apply it to bioinstrumentation question. Yeah, it's a tough call. The theory is biomechanics, application is instrumentation. But let's just say this is bioinstrumentation, because any question they set on dialysis, it's going to sound very similar to this. Hemodialyzer, right? Numericals will look something like this. So 2-mark question. Okay, fine. Resting state voltage outside the cell membrane compared to inside is this. Inside. Sorry?
Bioinstrumentation.
Is the origin of bioinstrumentation question. You could either put that in HAP also. It's a very, very basic HAP question on things. But we are particularly interested about it from origin of biopotentials. So I'm going to add this in bioinstruments. 2 marks. It's a simple recall based question. Then, okay, tensile strength of a degradable suture used for surgical procedure. Where is this from?
Biomechanics.
Biomaterials.
Yeah, see, notice it's not directly a viscoelasticity question. They just say, decrease exponentially. And it's also some degradable suture. It's a proper, and it's from Parton. It's okay. It's a biomaterial question. Biomaterials, 2 marks. Notice the exponential fit problem. Remember that. Okay, 60% kg person standing on 1 foot. So and so. The weight of the foot is this. How about this? Okay, biomech. biomech, it's a 2 mark question. Then temperature of bone cement. See, thermoelasticity is not there in biomechanics. For that reason, I'm again going to add this in biomaterials. Biomaterials, this is a 2 mark question. Bone cement, specifically, in fact, a question pertaining to bone cement. Then, yeah, finally, we have some medical imaging questions. Patient is initially here, imaged at a MRI question, medical imaging 2 mark questions. Okay, let's take a step back. Any of these questions hard? This one question, although it's an exponential fit question, I'm just going to mark that as hard because it's difficult to guess the kind of exponential relation here. So whoever keeps track of biomaterials, just mark a hard question there.
Sir, that GFR one, the glomerular filtration rate question, is that hard or?
Actually, that's a fair question. This is also actually not, unless you do get the numbers 4-5 times incorrectly, then only you realize, okay, there are so many unit conversions. There are like 100 pores, and there are n pores and all. So this is also hard. This is hard. Tensile question is hard. Trochanter knee ankle length, all this is easy. Even thermoelastic material, this is, if you understand the question, this is easy. Okay, is this easy or hard? Yeah, by now, whatever we did, we expect this to be easy, okay? If they have no background in medical imaging, it might look hard, but whatever prep we have done, this should be easy. Okay, couple of easy questions. Amplitude reflection coefficient, medical imaging, 2 marks. It's an easy question. And then forward bias current silicon diode. Okay, this is from analog electronics. Is it a easy or a hard question? It's an easy question, and it's a particular type of question. Can anyone recall what kind of a question is this?
Diode characteristics.
Diode characteristics? No, but at the end of the day, the relation will be exponential. Exponential fit problem. Take log on both sides, find some parameter, find it for its value. Exponential fit type of question. A random variable probability question. It's a math question. This is hard to do unless you know what the trick is. Hard math 2 mark question. Okay. This is hard. Then notice gradient of magnitude of the gradient of the function. So 2 mark, easy to do this double integral. Always they ask this 2 mark, math easy, no traps, nothing like that. And gynecologist recorded the blood pressure of patients shown here. Okay, regression curve. This is again from math. Apply to bio instrumentation appears like that, but it's a simple math question from statistics. Should we mark it as easy or not? Yeah, especially this question, there are shortcuts to do this. I'm going to mark that, leave that as easy. Person standing in this thing flexes by so and so. Biomechanics question on if you know what the terminology here is, TKA line, what is flexing, you can easily answer this, get this 2 marks. Then fine. Chest radiograph, image formation digitization question again is pretty easy, medical image. Then yeah, couple of questions from medical imaging, X-ray, so and so. Medical imaging 2 marks. Is this, at the end of the day, if you know what happens, this is easy. This also, except for this one detail, I would say this is easy. Okay, but that's a very, very simple detail. How many pixels does this corresponds to? So that is easy. Wavelength of an accelerated thing, basic physics in medical imaging. Yeah, electron physics. What is the energy of an electron, so that now we can start comparing things. And then we have this is medical imaging, very basic physics. It's an easy question at the end of the day. And we have a permanent magnet moving coil instrument having so and so. So where is this question from?
Measurement and control.
Yeah, this is specifically from measurements. We have 3-4 devices, PMMC, and a couple of things. So measurements. And 2 mark, it's an easy question. The relation here is just simple recall. Arterial blood extracted from healthy adult, oxygen partial pressure is this, total oxygen content of the arterial blood is this. Where should we put this? So this has to do with blood gas. I'm going to put this in bioinged, and then this at the end of the day, this is a hard question. The reason being, this question had a trap, the unreasonable trap. So this is a hard question from bioinstrumentation. So this comes under analysis of blood gases. Electrochemical, the typical thing application is, okay, can you measure concentration, partial pressure of oxygen, saturation of oxygen? Notice measurement of blood flow using a C-clamp magnetic flow probe. This is bioinstrumentation. And 2 mark, it's very easy. If you know the voltage generated is BLV, and you can also relate that to flow rate pretty easily. It's a simple question. Okay, this is the last question from here. A cell is injected with current, produce a change in intracellular mobility. Model this linear system. Where is this one?
Bioinstrumentation.
Okay, how about others? Yeah, this is actually a nice question. This is, at the end of the day, they want you to find a convolution. Convolution applied to bioinstrumentation, okay, but you need to know how to do this convolution. So I'm going to put this in signals and systems, 2 marks, and at the end of the day, this convolution is easy, but they have some tricky sign conventions here. Injected with a current, because of that, some signs and all that change. And let's just put this signals and systems questions. Let's put it as we haven't done it many times. Especially, it's easy to make a fall for the sign here. Okay, so there's a last question. Go and update our 2020 paper. Hopefully, those who started are over here. Okay, engineering math.
11 marks, sir.
Just 11 marks?
Yeah.
Okay, and how many was on?
2.
2, thanks. Thank you. Okay, HAP.
HAP and Biomechanics combined, 8 marks.
Oh, you combined it together, is it?
Yes, sir.
Okay, fine. Okay, 8 marks.
And 1 hard question.
How many marks for that?
1 mark.
Okay, again, 1 mark for this. Okay, fine. Sensors. Who is there for sensors?
Yes, sir. Bioinstrumentation and sensor together, there were 8 plus 14, 22 marks, out of which 2 were hard.
Okay, do you have it as separately sensors?
No, sir. I did it together, like bioinstrumentation.
Okay,
I just figure it out, sir. Yeah.
Okay, fine. Tell me what it is. Fine. Oh, you see, as far as we have like 60, 100 here, that's not repeated. Okay, what did you get?
Yes, sir. So there were like 22 marks in total for bioinstrumentation, out of which 2 were difficult questions.
And how many marks for those 2 questions?
2 marks each for
So
difficult
4
one.
marks.
Yep. Yeah.
Okay, fine. Medical imaging.
13 marks, sir.
Okay, 13
And
marks.
2 marks hard.
2 marks per hard. What was that hard question?
Sir, V is equal to MRI equation. Theory based.
Okay, fine. Yeah, fine. Biomaterials.
5 marks.
Okay, and hard.
2 marks.
Okay, 2 marks. Thanks. Electrical circuits.
4 marks.
4, and hard questions.
2 marks.
2 marks. Signals and systems.
6 marks.
6 marks.
Hard 2.
Hardest 2. Okay, fine. Analog electronics.
2 marks.
Oh, analog is just 2. Okay, this hardest. That was an easy question. Digital electronics.
3 marks.
Out of that, the hard questions are
1.
1. Okay, fine. And
For analog, it's 4, so 4 marks.
4 marks. Now, whether okay, fine. Oh, this is 4, is it? Analog is 4 and digital is 3. Correct? Okay, unless the student interrupts, I'm not going to change it again. Measurements, I think we have some measurements.
4 marks, sir.
Jiva, thanks, Jiva. And was there any hard questions?
No hard questions.
Okay, no hard questions. And at the end of the day, we have 4 marks, right? And
No hard questions.
control systems, yeah, steady state unity. I thought I marked this a hard. Okay, fine. Let's leave it. Okay, so quick sanity check. What is the summation here? Can someone quickly, couple of you try this?
99.
You missed a mark somewhere. Who was it? Okay, now this is verifiable. Okay, that is, we can go back and see where we missed that mark. But let's not do that. It's 1 mark. But quickly, what is the pattern we see? Interestingly, engineering math, yeah, at the end of the day, sometimes this happens. They don't give you 12 marks and all that, 12 or 13 marks. They have been giving 11 or 11 marks, something like that. And then the scoring subjects clearly are this. Okay, in this paper. So this region, notice, in fact, let me also add this region. You have like quick total there for the core subjects. Let me also have this thing here. Okay, what is a quick total there?
48, sir.
And someone else do that? I have a different number.
74.
74.
74.
Yeah, notice. So we have like 74 here, okay. 74 here. And of course, we have like, this is 26. 15 and 11 is 26. That means in this chunk, we have 74 minus 26, 48. So this chunk corresponds to 48. So this is what I am mentioning. And let's also, quickly see like how many marks, some questions are going to be hard. So if you miss out of the 74 marks, let's say how many are you going to miss? 5 plus 10, 14. Okay. So notice out of this 60 is gettable. Okay. This is just by looking at the core subjects. So which is one of the reasons I call this a very easy paper and a very BM friendly paper. If you just focused on these subjects, if you know it reasonably well, even skip hard questions, at the end of the day, you will get something like 60 with decent practice. Okay. And this boils down to 17, 21, 25. Okay. One could like totally afford to skip this. And, you notice there are easy questions here. So this count is just 5 here. So there are easy marks here, even if one had to totally skip that. This paper, one should score 60 very easily. Some basic preparation. Okay. But, All India rank 1 scored 41 because things were so uncertain. Okay. Now let's do 2021 paper. This paper, let me do it pretty fast. Okay. Can we again keep track of the same team, the team here?
Yes, sir.
Okay, hopefully the team.
Yes, sir.
Okay, thanks. So I'll do this pretty fast because of our time, and then we'll make the comparison. Okay, MCQs, we start with 1 mark questions. Not allowing me to write this one. What shall we do? If I say things, will you keep track of it? Okay, let's do that. Okay, aptitude first 5 marks. Then first 15 marks. Grammatically correct, easy symmetry. Then we have identical cubes, probability that even number is actually easy question. Some symbolic manipulations, again easy question. 4 persons seated, number of seating arrangements possible. Not a very hard counting problem. This again is easy. Planar field, you have traveled 3 units, north, south, east, west type of question. This is easy. And then we have a text inference question 2 mark, that is easy. And then we have some football players play cricket, all cricket players play hockey. I would say this is a hard question. This is a logic based question. If we don't know how to deal with logic question, okay, it's very easy to make a mistake here. And yeah, this I would say is a hard question, okay, 2 mark question. Then calculating this area, it's a very basic geometrical question. It's easy. And then equilateral triangle PQ or PQ, I would say is relatively hard because the question is framed in a hard way. Okay, so here let's just say out of this 15 marks, hard questions would amount to 4 marks. Okay, I think the team should be ready by now. I'll finish this very fast. Okay, first we have all the 1 marks. Math question, probability, integral of this should be 1 mark question. Scalar function is this, what is the directional derivative? Simple 1 mark question, math. Then 3 resistive loads connected like this, what is the voltage across AB? Okay, PAB. Simple electrical circuit question, 1 mark. It's easy, no traps, nothing. Ideal inductance is this, connected to sinusoidal AC voltage, energy stored in the inductor, maximum power delivered to the inductors. This from electrical circuits, I would say this question is hard because there are some ambiguities in the question. Because of this is hard. Electrical circuits, 1 mark. Xj omega Fourier transform, Xj omega is this 10 e power so and so. What is Xj of omega? Is a relatively difficult signals and system question. Okay, you need to recall a lot of properties and apply them correctly for the same function. Prone to mistakes. So it's a signals and system question. It is hard. This 1 mark is hard to get. Then in this circuit, 2-bit output of the combination logic. Okay, we have a digital electronic question. And what is the maximum value of y? Many felt this question was hard. Those who gave the exam. After that, now okay, you can backtrack and make things faster. Yeah, but you have to try 16 combinations and see what the maximum is. That was the initial thought. So this is a hard 1 mark digital electronic question. And then in the block diagram shown below, analog signal is this. So there's a question from analog to signal processing in one could say this bioinstrumentation, analog digital electronics, but this result goes to actually signals and systems, proper signals and systems results. So this is a S&S question, signals and system. This 1 mark is also hard to get. One has to recall that relation and apply that correctly in this odd looking schematic. So hard 1 mark signals and systems question. Then we have is this control system or signals and systems? Stable second order system. Yeah, okay, let's put it in control systems, peak time, price time. Okay, control systems. Okay, if we have to complicate that second order system question, this is an example. Okay, you have to look at it in the limit of something and then see what happens. This is a hard question, hard 1 mark question. Control systems. Which of the following displacement sensor is not to have a high sensitivity? Comparison of sensors. So this is from sensors and bioinstrumentation. Relatively easy question. Again, another question, temperature sensors for bioinstrumentation. Sensors and bioinstrumentation. And this is a hard question because you need to know why one of that actually works better compared to thermocouple will work, RTT will work, thermistor will work. But why thermistor is slightly harder, tricky detail. And only a thermistor will work. That is the most tricky part. It's not like there is some RTT that will work here. It's a hard question. pH of blood is in a healthy human is precisely this. I'll put it in, anatomy and physiology. A recall question. So this is easy. Which of the following is a cranial bone in the human body? Anatomy and physiology. Nothing to do with any joints or something. So this is proper anatomy. Okay. And then which of the following glands produces thyroid stimulating hormone? Again, anatomy and physiology question. Which of the following causes myocardial infarction? Anatomy and physiology question. if you consider blood as a suspension, RBCs in this, this is an applied biofluids question. And this is also relatively hard because once you say the answer, it's easy, but if you don't say the answer, it's hard to imagine what the RBCs will do. Biofluids, so biomechanics, hard one more. Shown in the figure, contact angles is this. It's actually from biomaterials. The contact angles is the standard parameter they measure. So this is relatively okay from
Easy, sir.
Yeah, this is actually easy. Imagine something in a water surface. What is hydrophilic and hydrophobic. This is easy. Biomaterial question, 1 mark. Which of the following is a bone resorbing cell? This is HAP. Okay, although it gets to microstructure of musculoskeletal system, some of these things is somewhat HAP. We are still in the 1 mark questions. I think we get started with medical imaging. So this is easy question. What happens to X-ray? This thing. This is relatively easy medical imaging question, theory question. Question 19. Pinnate muscles provide muscular force. Okay. Right now, certainly this is an easy biomechanics question. Just 1 mark. Which of the following may cause failure in bone implants? This is biomechanics or biomaterials?
Biomaterials.
Yeah, that is actually biomaterials. You need to know what is what. In fact, the definitions are given right away. Let's say the 4 definitions. Let's say this is relatively hard questions, at least prone to mistakes. So 1 hard question from biomaterials, 1 mark. Then we have again continue with 1 mark questions. Question 21 is engineering math, minimum value of a function. This is actually easy, not at all hard, although it's multivariable calculus. Then this question, continuation transfer function h of s is this, discrete time is this, bilinear transform. Where is this from?
Signals and systems.
Yeah, this is from signals and systems. And this bilinear transform specifically shows up from the FIR, IIR filters. Okay. Now, most did not remember what a bilinear transform was. So they couldn't do this. Let's say this is the hard 1 mark signals and systems question. What a bilinear transform is? It's easy, but no one recalled it. So this is hard signals and systems. Bode plot, intersection of this thing, acceleration error constant. This is a proper control system question, and it's hard. 1 mark. Okay, this was hard. Radioactivity of a radionucleotide with decay constant is okay. Easy medical imaging question, 1 mark.
Sir, just that out these questions are 1 mark or 2 mark
Which one?
after 20.
We are still in 1 mark questions. So we are still in 1 mark. Okay. So 24 is medical imaging, easy, and then polymeric scaffold is a biomaterial question, 1 mark. That is also easy. And then, okay, this is where we get to 2 mark questions. So I suppose from 26 to whatever follows, all of them are 2 marks. Okay, trace and determinant, math, 2 mark, very easy question. Unit step is this, output of the system. This is a signals and systems question. You could say it's also a control system, but no steady state error, none of that. Just output of the system for the impulse response. Let's just say this is signals and systems. This is easy. Yeah, this is easy. This is a math question. Hard. No one knew that for the transport equation there is this property that if initial condition will just shift over time. Hardly anyone, they were trying to solve this even weeks after the examination. They couldn't get the solution. Hard 2 mark math question. 28. In the electrical circuit shown below, the current flowing through the resistor is. This is electrical circuits, and this question is relatively hard. You have to apply a couple of Thevenin circuit and all that very carefully, else you'll get incorrect answers. Hard 2 mark electrical circuit questions. This one appears to be a which
Sir,
one?
I think it's easy, sir. It's a Wisdom breeze and Thevenin's equivalent.
If you know what a Thevenin's equivalent is and how to apply that properly, it's easy. But trust me, most made a mistake here. Even after saying, okay, you have to apply a Thevenin's equivalent, they really couldn't see what was parallel, whether R1 and R2 are parallel or R1 and R4 were in parallel in the Thevenin circuit. Okay, there's a hard electrical circuit question and 2 marks. So we have a signals and systems question, discrete convolution. Notice again a question on convolution. I already showed an example from that. Typically, one convolution shows up in the paper, whether it's discrete or continuous. This convolution always shows up. Doing convolution not that difficult. Okay, certainly we'll learn this. So, yes and yes, easy or hard?
Easy.
Okay, we will learn how to do a convolution, and it's actually just 4 points here. Doing the convolution also is very easy. So this is easy signals and systems. A block diagram, infinite IR, infinite tap, FIR filter, or transfer function is this value of alpha. This question appears very, very hard. This is from signals and systems. But at the end of the day, if you know what this schematic is, it's very easy to answer this.
Yes, sir. IR realization and FIR realization.
Yeah, it appears very hard, but at the end of the day, it's a simple geometric progression problem. At best, it's medium question, not a hard question. So this is signals and systems, 2 marks, easy question. Analog signal is sampled at 100 megahertz to generate 1024 samples. 1024 FFT, separation between adjacent frequency points is. How about this? This is from S&S, basic Fourier, fast Fourier transform. But n points here correspond to n points there, and it's actually a very simple question. Okay, easy or hard?
Easy.
Easy, right? Okay, those no anti-signals in systems, you would say this is easy. Easy 2 mark question from S&S. And then in the circuit diagram shown below, op-amp, analog electronics, no one could do it in the exam. You could do this very fast, but hardly anyone did it in the exam. So it's a hard analog electronics question, signal conditioning, op-amp circuit. 2 marks, very hard, analog electronics. And then digital electronics, even after giving you, if one were to give you all the formula, you may not be able to actually solve this. Hardest, I would say, in the whole paper. Digital electronics, NMOS, very hard to do this. 2 marks, you're likely to miss this 2 marks if this question shows up again. Where is this from? Accuracy and precision.
Measurements.
Yeah, measurements, notice, accuracy and precision, given some data points, calculating that is very, very easy. Just that, given in a data interpretation format, typical GATE type. So, this is easy, okay. Some make mistakes, but at the end of the day, this is easy. From measurements, 2 marks. Closed loop characteristic is this, frequency of oscillations of the closed loop system at steady states.
Control system.
Control systems, and again, given roots, finding whether whether it will be a steady state oscillation is very, very simple. You need to know what is what, okay. Substitute this here and it should be a root. If you know that, you can just verify this. It's an easy steady state oscillation control system or signals and systems.
Control systems.
Control systems.
Yeah, characteristic equation, typically, okay, control systems. Scanning electron microscopy. This is a biomaterial. So there was a newly added syllabus in the biomaterials. This question is from that. Okay, and this is actually, at least for the first time, it was hard because mappings are ambiguous. So hard biomaterial question worth 2 marks. ECG amplifier, surface EMG amplifier. Bioinstrumentation question, and it's actually, by now we should know what is EMG range, amplitude, and all that. This is an easy question, simple recall based question. Which of the organs secrete what? HAP question, relatively very easy, 2 marks. RF pulse is applied, okay, gyromagnetic bandwidth required. MI question, very simple, 2 marks. Longitudinal pressure wave, the pressure wave propagation angle in the kidney tissue intensity is. I would say, we know the theory and all that, but some of you may not remember that angle formula. For that reason, let's say this is a 2 mark hard medical imaging question, because this is not at normal incidence. This is at angle of 60 degree, incident at angle of 60 degrees, so that even the recall relations become slightly harder. Novel biomaterial was tested, biomechanics, and it's easy, 2 marks. Electrical circuits, we are still in all of them, okay. Rest of the questions are 2 marks. LR circuit, which is cascaded, we want to know whether it's high pass, low pass, overdamp, underdamp. This question is hard unless you remember few things you have to do a big derivation. This is not from electrical circuits. The second order electrical LR systems. Bioinstrumentation. This is measuring cardiac output using thermodilution. Again, there are problems in this question that make it hard. Let's say this is a hard bioinstrumentation question, that is 2 marks. Then we get here. Smooth muscles are found in walls of hollow organs. Yeah, this is a HAP question, but specifically it's smooth muscles. Yeah, where it is found, what is being controlled by, what is their texture, is a proper HAP question. There are 3 pointers here. You have to recall a lot of things. Did anyone who went through Kaon, do you find this easy? Have any of you went through Kaon right now? Let's say, okay, so many conditions. Let's say, let's say you miss 1 or 2 options and then get the question right. Let's say this is a hard HAP question, 2 marks. Considering unity feedback system, steady state error with respect to unit ramps. This is an easy control system question. Okay, steady state error, unity feedback. Yeah, you have to be careful about certain things. It's a closed loop transformation, but easy control system question. 2 marks. Diameter of a renal artery, Reynolds number is this. Again, another easy question, but the units were hard for most. Certainly this year we are much better prepared. So it's an easy 2 mark question again. This is from biomechanics. And drug manufacturer believes that 95% chance, so and so. Okay, this is math, Bayes theorem, probability, easy 2 marks. Measurement process of groups A and B is this. Standard deviation is this. This is from statistics, again math question. Sometimes it gets hard to recall some of these relations. Let's just say it's a hard math question from statistics. 2 marks. Okay, SPDT switch is opened and closed. Energy dissipated in the resistor. It's a simple electrical circuit question. It's also very easy if you know how to do it. So this is an easy 2 mark from electrical circuits, and this is from analog electronics op amps. Just that there is a positive feedback loop here. Most of them made a mistake. This question also was set for you to make a mistake. So this is a hard analog electronic question worth 2 marks. Pacemaker was implanted in cardiac patient. Battery is this. Yeah, now this estimation of battery life. For each pulse, it supplies this much amount of charge. So total, it can supply this much amount of charge. What is the lifetime of it? Typical question, always expected. I already pointed out one question there in 2020 paper. It's a bioinstrumentation paper, a relatively easy question or expected questions. Okay, for 2 marks. Okay, we are very close to the end of the paper. Medical imaging, easiest 2 mark medical imaging paper, perhaps in the whole paper. Easy 2 mark question. Radioisotope is this, nuclei is this, radionucleotide in picograms. Again, you have to do some unit conversions, but at the end of the day, it's easy. So this is an easy medical imaging 2 mark question. PCT crystal is this, emitting a blood vessel at an angle, Doppler shift in the ultrasound way. Yeah, notice this is ultrasound applied in a Doppler shift for blood flow. And this is bioinstrumentation or medical imaging? Where do you want to put this?
Medical imaging.
Yeah, this is medical imaging. Okay, a proper ultrasound Doppler. So this is medical imaging, and this is also easy. We know how to make the conversions very easily from going to thickness to frequency to finding the shift is very easy. So it's easy to question. Okay, so now this is the end of the paper. Now let's.
40-second question.
Okay, someone has question trouble with this question. 40-second.
Yes, sir.
This is a estimate tensile strength, right? And it's a biomechanics, basic biomechanics. Might look like biomaterial, but Young's modulus is the starting point of biomechanics. Okay, now let's go here and yeah, let's make this best. Hopefully, again, the team is here. So even some of the things I don't know. Yes, Urvi, please.
So 11 marks and hard marks are 4.
11 and hard is 4. Okay, so someone has a question in the chat. Yes, the thermodilution question will be bioinstrumentation, and that's also a hard question. Okay, thanks, Ubi. Then Swarnendu.
So HAP is 9
Okay,
and hard marks is 2
okay,
and biomechanics 6 Hard is 1.
Hard is fine. Thanks. Sensors.
Sure. So sensors and bioinstrumentation, 6 marks, out of which hard marks are 3.
Sensors and bioinstrumentation is 6. Hard is
3, sir.
and medical imaging
12 marks and hard is 2.
12 marks. Hard is 2. Point of going through this exercise is to now we are at a position to strategize. Biomaterials.
4 marks and hard is 2.
Okay. Now let's also make a quick count here. So this is out of, again it's 26, right? Isn't it strange? They only ask you for 11 marks. Okay, but that's what they do. Out of 26, you can score. This is 5 marks. You miss 8 marks. Even if you had to account for this hard questions, one should suppose to get, let's say, 18 here. Let's fill up the rest. Electrical circuits.
8 marks.
8
Hard
marks.
is 5 marks.
Hard is 5. Okay, fine. Signals and systems.
11 marks. Hard is 3.
Hard is 3. Then analog.
For analog, it's 4 and the hard is also 4.
Okay, 4 questions. 4 of them are hard. Fine. Digital electronics.
3 marks, sir, and all 3 is hard.
All 3 are.
Hard.
All 3 are hard. Digital electronics. Okay, fine. Measurements.
2 marks, sir.
Thanks.
Easy questions.
Thanks, Shiva. And they were easy, right? Okay.
Yes, sir.
Okay, fine. And control systems.
6 marks, sir. 2 were hard.
6 and 2 are hard. Yeah, now comes the time to strategize. So let's look at one at a time. Okay. So sanity check. What is the total here?
97.
We are doing bad. Is that total correct? Did someone else also getting 97?
Yes, 97.
Yeah, probably this time, we couldn't write it down. But that's fine. Let's see at least. Still start comparing. Okay. First question. What are we getting? Engineering math. I would say, just with this, you can reach close to the cutoff. The point of this is to take you close to the cutoff. This paper was certainly hard, and we have also properly accounted for that, I think. 18 out of 26, certainly gettable, and realize at this point you are very close to the cutoff. That is the reason to emphasize engineering math and aptitude. And we have looked at the concerning theory. The mock test will get a chance to look at the things again and again and revise. So 18, in fact, I would say 20 plus 22 plus is what I expect, but at least, okay, some questions are hard, fine. In that case, 18 here is, you can't negotiate on that. Let's get to the score total here. What do we?
63.
63, and out of that, so this marks will be
37.
Notice some of our high scoring subjects, sensors and bioinstrumentation. Okay, just 6 marks, right? They almost doesn't do justice and all. There is so many questions from sensors, so many topics from sensors, so many topics from bioinstrumentation. Doesn't do justice at all. But at the end of the day, okay, that is what they asked. No bioinstrumentation questions. Even there, okay, we had like 63 out of 100 marks, right? So probably you missed some questions here, likely. The 3 marks missing somehow fall here, because I know this total is 65. Okay, and out of this, how many marks are hard? Okay, the total here is 8, and this is 2, 1, 6, 10. Now 18. This is okay. This is one thing. Why I say this paper, 2021 paper is very hard. Reason being, notice all the other subjects, signals and systems, electrical circuits, control systems. So many marks from those topics. Certainly, S&S we didn't expect, and control systems, they also, many questions we thought were out of syllabus questions were there. Okay. And bioinstrumentation core topics, nothing. So paper with an abrupt change in weightage, there, even in that paper we have like a 63 marks from the core topics. Out of that, let's say you don't get this hard 18 marks. What are you left with? What is one left with at the end of here? That is, what is the easy marks gettable with the core subjects?
45.
Yeah, with this one could score 45. Okay. So out of this 37, 48, 37 here, notice accounting for hard marks, roughly you have like 40 marks from this core topics. Out of those 40 marks, you can certainly score 30. And 30 here, 18 there, you should get 45. This is a number that I am urging everyone to focus on. This number is just take a hard GATE paper, 2021 paper, okay, that is not BM friendly, because bioinstrumentation and all just 6 questions. Even in that paper, if you can get the easy questions here, you can score 45. 18 from engineering math and aptitude, roughly 30, 30 or even 27, something like that, you should get 45. So this is a strategy that I have been emphasizing. Okay, and this is the place where students also make a mistake. Okay. What happens is, there is a tendency to always learn more about everything rather than know strongly about few things, right? So one of the points of this comparison is to make sure that again, so always focus on BM. That should get you. This was all India rank, all India rank 6 in 2021. And if you are there, even if you get some very easy questions here, you should certainly get the current all India rank 6 is going to be higher, 55 or something like that. You can easily get up to that place. Okay. So one strong point is this point clear. Focusing here is the right thing to do. Okay. Is there anyone who doesn't agree with that?
I agree, sir.
Yeah. And your strongest scoring is medical imaging. We did that first. Everyone here has done that. And with the amount of preparation we have put in, we should score as much of those marks as possible. Then even there are variations here and there. I'm talking about not just clearing the cutoff. Clearing the cutoff, I spoke about in engineering math and aptitude. I'm talking about shining in GATE exam. 2021 paper is, I would say, BM unfriendly. Bioinstrumentation, there are so many topics, sensors and bioinstrumentation, or don't ask anything from it. Put so much emphasis on signals and systems, very hard electrical circuit questions, and very hard, almost out of syllabus control system questions. Because of that, I would say 2021 is unfriendly. That is biomedical unfriendly. Even in that paper, if we know this very well, we can shine very well. Okay. Then what was the other question you're talking about? Weightage, most weighted subjects, you could clearly see medical imaging, general aptitude certainly, engineering math, and medical imaging. Okay. Then if you kinda know this reasonably well, HAP, biomechanics, bioinstrumentation, biomaterials, I would certainly consider this as scoring subjects. They have to again and again ask that Reynolds number, Imersley number, Young's modulus, ultimate strength. In the worst case scenario, they will ask you thermoelastic strain, stress, and all that. And few other things also should be evident. Digital electronics is vast, but so far the focus is very little. Weightage is very little from that. Even if 10 marks shows up from that, it's not going to affect you. The 10 marks in signalization system might likely show up in digital electronics. Okay. And then measurements again is vast. Knowing that, I know if you are skipping this and this combined together, you are skipping less than 10 marks. This is something again I have been saying since even before the 2020 paper. Digital electronics is something that I may consider skipping. Measurements is something I would consider skipping if I don't have time and all that. What else do you want to say that? Yeah, let's fill up this table and wind up. Some 5 minutes. So based on whatever numbers we put, what is the total difficult marks here in this paper and in this paper? What is the total, sum total for 2020 paper? All the hard marks put together?
19.
Okay, so we have till here it's 14 and then 5. So we have 19 marks is not gettable. And of course, some students from our batch did score 60. They could have scored 65 and all that because they mentioned about control systems. Okay, how many difficult questions here?
35.
35.
Yeah. So I think we have a very clear answer to our first question. Here 20 marks is not touchable. Here 35 marks is not touchable. So you are escaping from left 65 marks. Okay. So certainly hard. Okay. And this was easy. So couple of points. So let's look at that hard paper. Out of 65, our students have scored 61. Okay. And even if at this stage, okay, I'm going to focus on this, you can score 45 plus and you are in very good shape. We will certainly, of course, look at the basics of this. Whatever easy questions are here, easy marks will certainly score them. But just focusing here, just in case you don't have time and all that, should help you shine in GATE, first point. Okay, even in a hard paper like this, 35 marks hard questions is reasonably a difficult paper. And let's go to our second question. So this answer is based on numbers. Which is more biomedical friendly? Biomedical friendly marks here is 74, here it's 63. And let's also make it friendly. So 74, 14 is hard. How much can you score? You can score, if you take out this 14 hard marks, how much can you score there? 60, right? Biomedical friendly marks is 60 here. And the biomedical friendly marks in this paper will be 63 minus 18. Yeah. Now, yeah, this figure looks all that complicated, but now does this tell you a very, very clear picture? I mean, this is friendly, that is taking out all hard questions. What are the easy questions from biomedical topics? You have 45 marks. And you know what those easy 45 marks could mean for your GATE, rank or score. And this is an unfriendly paper, BM unfriendly paper. In that unfriendly paper, if you know biomedical topics very well, you can score 45 easily. also let's look at non-BM friendly marks. So we have like quickly 25 minus 5, we have like 20 marks, and here we have like, so quickly, what is the total here?
34.
Yeah, thanks. 34. Out of that, 17 is hard. So that makes it 17 marks you can get. Okay. So focus here. Learn basics. Learn basics. That is the strategy based on even looking at an unfriendly paper. That is a strategy. Okay, then let's quickly, most important here, 2020, there is a one difference. Medical imaging, that's a constant in 2020, 2021. So MI and MI, and then roughly, okay, bioinstrumentation was important here. It wasn't. That became kind of like a least important. Bioinstrumentation. Then what other important topic is there? Biomechanics. HAP and biomechanics are any 8+ marks is Biomech. Looking at HAP and Biomech. And that combination will always be there. Okay. HAP, biomechanics, biomaterials. This combination is there. Biomech. Okay. Least important here, you could easily say, measurements, digital electronics. Measurements, digital electronics. Even ADE to some extent. Measurements. ADE. Yeah, measurements and ADE. Electrical circuits became kind of important. This is signals and systems. Circuits. Again, ADE. Okay. So yeah, we went through a very, very messy table here, but the point of that is to get very actionable insights to strategize. And we have some very hard numbers here. Take 1 or 2 marks here and there. That's fine. But so even in a hard paper, focusing BM friendly things still BM friendly, even the hardest paper. Focus on that, learn the basics, and the mock test will give a spectrum, combination of 2021, 2020, so that you get a feel for all types of papers. We are not going to stop learning topics, concepts, once we finish bioinstrumentation. We'll certainly try to cover as many concepts as possible. Any questions on strategies or any other questions, comments you have, raise it.
No, sir.
No, okay. And Vaishnavi did, you asked for something, but you got something else, but did it meet your expectations, that is requirements?
Yes, I actually wanted this exactly like this.
Okay, you wanted exactly like this. Okay, that sounds good. Others, anyone still thinking about, oh, I did not learn electrical circuit, I am nervous, I did not learn signals and systems, I am nervous. Anyone like that? Measurements, oh my god, should I skip? I don't have time at all to even open measurements book. Anyone wondering that? Oh, you're wondering?
Systems, sir.
Uh-huh.
I find it really hard.
You?
I find it really hard, signals and systems.
Yeah, see, if it is hard, skip it. Okay.
Yes, sir, that's what I wanted to ask.
Worst, what is going to happen? 11 will be 15 marks. My suggestion is put that focus on the rest 85 marks.
Yes, sir.
Okay. Signals and systems, yeah. It's a lot of math. Basics I will tell you, okay, what's a linear system, what is a time invariant system, this system, that system. Very basics we will certainly learn. But even the questions that we have seen are relatively hard. Skip them. Skip the subject.
Okay.
And see, analog and digital electronics is like a ocean. Okay, they ask like 4 marks from this, 4 marks from this, and you have to spend tons and tons of time memorizing things. One problem with digital electronics, so many recall things. Right? Yeah. Okay. Then others. At this point, many students, the anxiety is lack of this one detail. If you have this, your anxiety should go away, your preparation quality should be better, and accordingly your performance should also be better. And notice these marks are not at the end of the day, we are not talking about cutoff, we are talking about in 2021 this is all India rank 6-7. Okay, so great. Any other questions, comments? You have like a clear picture. Only 4 months left. You know how to proceed.
Yes, sir.
Okay, so with that, then yeah, I should have planned this session for 2 hours. I thought 1 hour we all could quickly do that, but fine. Let's also hear from the other batch.
Yes, sir. Yes, sir. Now I got a clear understanding.
Okay, okay. So okay, then yeah, even Lingad or any
Yes, sir. We got clear understanding about it, sir.
clear understanding about it. Fine.
Yes, sir.
Okay. So and the focus here, I will also make it simpler. Single digit AIRs are not out of reach. That I can assure you. Last year students did not have such a nice collection. Yeah, if a question like this is there in the mock, okay, or in the GATE exam, Maxwell bridge, okay, I match the things and then get off with it. That shouldn't be the case. You should be able to match what is given to you. Then there is a bridge that is not given here. There are some standard bridges. We'll give that list. You should be able to recall what that bridge is used for. First thing. You should also know what a Maxwell bridge is. If given a circuit, you should know, oh, this is a Maxwell bridge, or this is a Kelvin double bridge, and all. You should be able to recall that. That is knowing things in and out. So each question is like a pointer to typically what they ask from here. You have to go probe nearby things. Okay. Then that is one example. Analog electronics. Okay, we have a comparator and a differentiator here. How about an integrator? How about a summer? Low pass filter, high pass filter? All the basic things, inverting amplifier, non-inverting amplifier, all the basic things. Then that is knowing at least the GATE syllabus in and out. Then you are in very good shape. Okay. So with that, I hope you got a direction, all of you. The strategy is based on numbers. Although I have been giving the same strategy even before 2020 exam, the strategy remains the same. Now I have some data to back it up with, and so we have mocks to help us structure our preparation, organize our preparation. Then rest is there in your hands. Let me stop here and then wish you all good luck. You are in good shape. You are already half past the ocean. Right, the syllabus ocean, you are already half past this. You are close to getting this 45. Yeah, some of us are lagging behind, but you can catch up. Just focus on that, catching up in this part. You should be good. Okay. So wish you all good luck, and let's stop here. Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yes.
Yes.
Thank you.
Bye everyone. Welcome. Bye.
Thank you.